All right, so I'm going to take you through assessing normality. So first thing, you'll notice that we have raw data here, points earned in 2022 for the teams in the NHL. So first I'm going to find the number of values that make up that table. I mean, you could count them, but the count feature will take care of that too. So I'm going to write equals count, and then I'm just going to highlight the column with the exception of the title, and then lock that in, and it'll tell me that there are 32 values in the list. I'm going to X out the autofill. I need the mean. Remember the line command for mean is average. Same deal. We identify the values that we want to find the average of, lock it in. Sample standard deviation equals, then start typing sample or standard deviation even. Then you'll see, as you go down the list, you'll see one that says standard deviation, stdev dot s. That S is for sample. So we'll grab that. And so now I have the number of values in the set, the mean of the values in the set, and the standard deviation. Now for the 68% rule, we have one standard deviation to the left of the mean and one standard deviation to the right of the mean. So what we're going to do is type in equals the mean minus 1 times the standard deviation. All right, that's going to be my low bound. If I hit enter, that'll lock it in. X out the autofill. For the upper bound, it's going to be the mean, which is in B37, plus 1 times the standard deviation. Again, X out the autofill. Now, for the 95% rule, we're going 2 standard deviations away, so I'm going to take my line command here, copy it, put it into the bar here, and then change that 1 to a 2. Do the same thing here, copy it right from the command line, paste it into the command line, not just the cell, but right up here in the command line, and change 1 to a 2. A little error. What's going on here? A little extra equal sign there. All right, so same idea. Copy it from the command line, paste it in. 2 becomes a 3. Copy from the command line, paste it into the command line in the desired location. 2 becomes a 3. And then we're good. All right, and so for the counts, I want Excel or Google Sheets to tell me how many values are between the lower bound and the upper bound. So I'm going to do equals, I'm going to use count if. All right, so, and you can kind of sneak around here, I'll show you. You know, if you look in the solution, you can see it. I mean, it's a pretty lengthy thing here, but it's essentially you're identifying where the data can be found, right? And that's B3 to B34, and then what the condition is, all right? So let me go back here. Equals count if. I'm going to highlight the data. I'm going to put comma, and then I want to indicate that I want the values that are less than or equal to whatever the lower bound is. All right, so less than, equal to the lower bound. Now, you'll see it in here too. When you click on, boy, I don't want to do that. If you click in here, you'll see that whatever the inequality is has to be in quotes, and we use an ampersand to connect the inequality with the cell. All right, so that's what I'm going to do here. Oh, I lost it, jeez. All right, equals count if. Again, highlight the data, comma, quote, less than equal, end quote, ampersand, and I want it to be less than or equal to the lower bound. All right, and then we're going to subtract from that what we get for actually, sorry, it's the upper bound first, and then close it up. You can kind of be sneaky here, copy it, So minus the same values, but this time I want it to be lower than the lower bound. So I was saying lower bound incorrectly earlier. So that would be in B41. All right. So it's saying take all the values that are less than or equal to 111.28, then subtract from that all the values that are less than 70.717. Lock it in, 21 values. And then I'm going to take that number and divide it by the number of values in the set. All right, so I'm taking this number here, equals whatever I have in D41 and dividing it by whatever I have in B36. And I see I have a value that's around 66%, so it needs to be close to 68%, and that is fairly close. All right, I'm going to do the same thing for the next row. All right, so same row references B3 to B34, but this time I want it to be referencing row 42. So do it again, row 42. Lock it in, equals, I'm taking whatever I have in D42 and dividing it by B36. So what they put here is actually pretty close, but not quite. D42 divided by B36. All right. Now these are percent values, or they're proportions. So what we could do is multiply them by 100 to have it in percent form. So I'll tack on a 100 times in front. Same deal here, 100 times. And then same idea, my references are going to change a little bit. So in this cell, instead of C42, it'll be C43 and B43. Lock it in. I can copy this and paste it in here. So that's, I want to make sure I'm referencing the right things. I want to reference D43, but I still want to divide it by my number of values, which is in B36. So we're good there. And so 66% is pretty close to 68, 100 is pretty close to 95, 100 is pretty close to 99.7. So this is close to a normal distribution. Now for the second part, we need to find z-scores. So we're still going to do the mean, so E equals average for this column. Sample standard deviation equals standard deviation dot S. Same column. The z-score is the difference between individual scores and the mean divided by the standard deviation. So for my first z-score, I'm going to open parentheses. I'm going to grab this value, subtract from it the mean, close it up, and divide by the standard deviation. But I'm going to throw some dollar signs around J37 and J38. Dollar signs lock it into position so that if I drag down a line, it won't change that row or column reference. All right, so that's my z-score for Florida Panthers. If I drag it down the line now, I'll show you one step here. See, J4 is there instead of J3, but J37 and J38 didn't change, and that's how we want it. So drag it on down the line, and you'll have your populated set of z-scores. The conclusion I'm looking for here is whether or not there are any unusual values. If there are any numbers in this new list that are less than -2 or greater than +2, then there would be unusual values. So there are no unusual values because all z-scores are between -2 and 2. All right, so if you followed along with this, you're good. Now go on to the assignment tab and basically do the same thing. Just this time we're talking about area for particular countries.